Question number 6. Two flasks of equal volume are connected by a narrow tube of negligible volume, all at 27 degrees Celsius and contain 0.70 mole of hydrogen at 0.5 atmosphere. One of the flasks is then immersed into a bath kept at 127 degrees Celsius, while the other remains at 27 degrees Celsius. The final pressure in each flask is. So the answer is going to be 0.5714 atmospheres. How it comes, let us see. See, here two volumes, equal volume containers I am taking. This is a flask 1, this is flask 1 and this is flask 2. Volume V and this is volume V. So total volume if you are taking, that will become 2V. Okay, volume is 2V. And pressure is given 0.5 atmosphere. Total number of moles given 0.7 mole. And temperature both are kept at 300 Kelvin. 27 degrees Celsius means 300 Kelvin. So these are the initial conditions given. And ideal gas equation PV is equal to nRT. Pressure is 0.5 atmosphere. Volume I am taking 2V because this is first volume V, second volume V. Both are of equal volumes. 2V I am taking. Number of moles 0.7, R 300. Now, from this you can say V is equals to 0.5 into 2 is nothing but 1. So V is equals to 0.7 R 300. Remember this we are going to use in the last. Now come to the condition. What he made is, second flask is kept in 127 degrees Celsius bath. But interesting point is both are connected only. This connection is still there. That means when its temperature is increased, whatever the pressure is there, the pressure will be maintained both in same cases. That means not 0.5, pressure will be increased in both. Don't think that only pressure is increased here and pressure remains same here. As both are connected here, number of molecules will be shifting from one to other. So definitely both will have finally equal pressure. So first flask pressure P1 is equal to N1 RT by V. Volume we can't change, R we can't change, temperature. Number of moles we are saying N1. And second P2 N2 R2 by V. But interesting point is P1 is equals to P2. And first one temperature 300 Kelvin. Second one temperature 400. So that I mentioned here. P1 is equal to N1 R 300 by V. P2 is equal to N2 R 400 by V. But both are connected. So pressure will be equal in both the cases. So P1 is equals to P2. So this is only asked finally. What is P1 or what is P2? So P1 is equal to N1 R 300 by V. P2 is equal to N2 R 400 by V. So V can be cancelled, R can be cancelled. So N1 300 is equals to N2 400, or N1 by N2 is equals to 4 by 3. And total moles are given to you, that is 0.7 moles are there. That means N1 is equals to 0.4 mole, N2 is equal to 0.3. Okay, 4 by 3 means if total moles are 7, N1 is equals to 4, N2 is equal to 3. If total moles are 0.7, N1 is equal to 0.4, N2 is equal to 0.3. Simple calculation. Now he is asking what is P1. P1 or P2, both will come same, no, don't worry. So P1 is equals to 0.4, number of moles P1. R is, we are keeping as it is, 300. And volume. This volume we are taking our first equation. Volume is equals to 0.7 R 300. That I am taking here. 0.7 R 300. Now R 300 can be cancelled. So 0.4 by 0.7, it is nothing but 0.5714 atma. One very interesting question.